Hi, and welcome to Amberdata. My name is Taylor, and in this video, we're going to be looking at our Web3 Data API and how you can gain access to this rich collection of valuable, highly useful blockchain data that's available in less than a second. So let's get started. We'll begin by logging in. This will assume that you've already gone through our signup process and made an account. If you have not done so already, you can watch our other video or read the blog post. Shouldn't be too hard. Great, now that we're logged in, we're going to head over to our API keys. From here, we're going to add an Ethereum mainnet API key so we can start getting data. I'm going to select this here and hit new API key. Great. In another video, we talk more about this in depth, but for now, just know you're going to need this blockchain ID. I'm going to copy that and our API key, of course, and we're going to copy that to clipboard. From here, we're going to view the API docs. Okay, so before we dive in, I'm going to briefly explain what Web3 data is and the usefulness of our endpoint. Web3 Data API is for blockchain-specific data. We'll have other endpoints for inter-blockchain communication, but for now, just know that this is what Web3 Data API is for. For example, if you want information pertaining to addresses, such as balance, listed transactions, first appearance on the network, etc. That's just the tip of the iceberg. There's so many more pieces of information that you're able to obtain from our backend services. So why use Web3 data if we have our Web3 provider, such as Infura or contacting a live node that we're running ourselves? Well, contacting a live node can be very slow. So why do that when we have the data for you at a much faster speed? In addition, in other videos, we show how you can actually verify the data that we have against the blockchain. So you can know that the data that you're getting is verifiable, trusted, secure, and a lot faster. Currently, we support main and testnets for both Ethereum and Aeon. However, we are just getting started, so be sure to watch out for what we roll out in the future. The overview here goes over a few things that I was discussing earlier. This is basic usage information, the things we'll need here, the API key and the blockchain ID. I'll show you where that is at later. Here's an example request and the blockchain IDs and slugs for reference. So on the last page, we copied that, but we could just get it from here as well. Responses. So every response will include the following fields: description, payload, status, and title. You can read more about those there, as well as the different errors that will be returned. Authentication, it goes over the necessity of an API key and how you can obtain one. There's a video on that as well. Types, a few important things to note here. Timestamps are all in milliseconds. Values returned will be in the lowest denomination of that blockchain. For instance, with Ethereum, it would be in Wei. And the records, it's an array of objects pertaining to your search. And then there's the total records, which will indicate the amount of objects that exist. It's really important to note that caps at 100 records per query. If you want to get the next 100, you have to use the page query parameter. And as well, the ordering will be in reverse chronological order. From here, we're going to go down each endpoint and give a brief overview of the data it returns and why it could be useful. Okay, so here we have the ABI endpoint. This is pretty straightforward. It returns the contract ABI for any address that we put here in this box. I'm going to paste in the CryptoKitties contract address. And like I said, within less than a second, we have our data. This part of the response body explains the success or failure of the response. But what we're interested in is this data field right here. It begins with the bytecode. And here you can see the contract API and some probably familiar methods from the CryptoKitties smart contract. And here we have the name and the source. So right here is the entire source code of the CryptoKitties smart contract. So we're able to get in less than a second the contract API of any address or smart contract that is by address from our backend services. There are even more use cases that we haven't even thought of yet, and I'm sure a lot of creative developers out there will find them for us. Here we go. Function calls from the CryptoKitties smart contract. Let's look at what they return. So each one of these is a record. We have the block number, contract code address. This is the block number that the internal message is called in. The depth, how many function calls did this particular internal message make? So how deep did it go in the call stack? Was there any errors? The from address, the gas, the input, whatever data that would be, we put there. Any leftover gas from the function call. Message index, what was the opcode? So in this case, it was a call function. So it looks like we're executing a method. And it has a return value of 0 or null. Timestamp, nanoseconds for null here. This is the address that it's going to. The transaction hash value, in this case was 0. I mean, it was a function call. So that's the blockchain ID for which this internal message is found. And move to the next one. This is the information endpoint. It returns information about an address. Throw in the CryptoKitties address. We're going to hit try it out again. That was much faster because we don't have 13 million records. Okay, so these are some useful pieces of information here. We have the first seen on the network, and this is when the address made its first transaction. So in this case, back in 2017, you can see that that's when the CryptoKitties smart contract address was first seen on the network. It's pretty neat, or at least this version, this smart contract at this address. We have the type, so it's an ERC721, right? It's a collectible. It's a CryptoKitty, so we have that there. Network, we use probability to determine whether it's on the mainnet or testnet of Ethereum. In this case, we know for certainty that this is a mainnet contract. We have another record here which associates a similar address but on Rinkeby, and it looks like it was first seen around the time that the CryptoKitty smart contract was seen on the network. But this gives you an idea of how we can have one address mean two different things on two different networks within the same blockchain. So by using this, you can know for certainty whether this address is a Rinkeby address or a mainnet address and how it's being used. That's one very helpful use case. So we're going to move on from this endpoint, and we're going to look at the logs endpoint. Here we have the logs endpoint, and it returns the logs of an address. We're going to look at CryptoKitties again. The logs of an address are going to be events that are fired within a smart contract, which you should be familiar with those. You can set events for when something happens and you want to broadcast that. So for instance, CryptoKitties sold, broadcast the event. You could even use the logs as a place of storing data too, but it's less used in that case. Okay, so here we have, looks like 5.7 million, not as many, But these are all the events that were fired from the smart contract for CryptoKitties. And we have the log index, transaction index. That's where it appears in the list of transactions. The transaction hash, block number, which block number did it appear in, the address associated with this log, data, and this is when an event is fired, you're able to actually throw some specific data into there, and that's where this will be right here. Size of the data, timestamp again, when it took place. This is really useful, and you can even go on our website and see on the UI how we're using this endpoint, where we can create graphs of we can watch for certain events and the data associated with those events, and we're able to create these graphs to show how often an event is fired based on a certain time. So we'd be using the timestamp field right here. You can also use this endpoint if you want to watch for specific events that are fired. So let's say you want to know, if you wanted to ask the question, how many CryptoKitties were born in the last 30 days? And you could use this endpoint to obtain that answer, which is pretty rad, especially considering the fact that you can do it at lightning speed. Let's go to the statistics endpoint. Now this just returns statistics about an address. It's a little bit different from address information, which is more specific to that address. This is going to return information around the address. For instance, you're going to see here information pertaining to its balance even. So here we go. So we have the balance, the current balance, and this is in way, the balance in, the balance out, the address type. In this case, it's just an address. Contract type, ER721 contract. This is the number of token holders. So how many people actually own this ER721 token? In this case, it's the CryptoKitty. And then number of times those tokens have changed hands. Again, a very useful endpoint, especially for the simple fact of just knowing the balance of a contract and being able to display that in a UI. I had a Stack Overflow question that actually asked about that. And it's a lot faster to hit this endpoint, get the current balance of an address than it is to hit a live node. That's extremely handy. This is a tokens endpoint. It returns the tokens held by an address. Throw in the CryptoKitties address. We're gonna hit try. So the reason I'm gonna guess that CryptoKitties has token holdings from airdrops. A lot of addresses would get airdropped tokens and just end up with a bunch of tokens. So here we can see a list of all the tokens. Looks like 64 tokens that this smart contract owns, or this address owns. It doesn't have to be a smart contract. We have the balance, which is the amount of tokens that this address holds in way, the blockchain ID, the address, so the address of the token smart contract, the number of decimals, so how many significant digits do they use with this specific token, like how much is it divisible by. The symbol, is it ERC720? No. Is it ERC721? Yes, it says true right there, so we know that. And from here, we'll move on. Here we are at the transactions endpoint. I'm going to put the CryptoKitties smart contract address in there. What this does is it returns a list of transactions of an address. And it should return, nice, about 3 million, it looks like, different transactions to and from this address. Right here is the transaction hash, which is just the hash of that transaction. That's pretty straightforward. Right here is something called a nonce, a transaction nonce. What this is it's actually the number of transactions sent from an address, which is typically used to prevent double spending. Moving down here, we can see the block hash. So the header of the block, the hash of that, the block number, So the number of the block that this transaction was included in, the transaction index, and all that means is the index of the transaction within the block. When reorgs happen, this number can change right here. This is the from address and the to address. We have the value sent. So in this case, it was 0. So no value was sent in this particular transaction. We have the input size is the size in bytes of the input data. So for instance, if this is a transaction that is making some sort of function or method call, a solidity method, there could be an input to that. So there'd be data associated with this transaction. In addition, if there's a contract created, that would also show up here as indicating a size in bytes, the input size of that transaction. This is the gas price, which is the price in way of that gas that was used. This is the amount of gas that was used. This is the price of the gas during this transaction. This is the cumulative gas used. So how much gas was used up to and including this particular transaction. This is the amount of gas that was actually used. This is the total amount of gas that was in the transaction to be used. This is the contract address. Since it's null, no contract had been deployed. Status of 1, good, means true. This is the number of logs that were included in this transaction. So when a transaction sends, there can be events that are sent along with that transaction or logs. Then we have the timestamp, which is again the time that this transaction took place. And we'll move on to this signatures endpoint. Now what this does is it takes in a 4-byte signature and returns information about it. For instance, this 4-byte signature that I acquired beforehand. And let's come down here. As you can see, this is the 4-byte signature for the transfer from method with parameters bytes, address, and uint 256. This is the hexadecimal signature that I just put in, the number of parameters, and the full hexadecimal signature right here. This is extremely useful. It's one of the ways that we are able to get the human readable names for our front end. If you go and look at the contracts tab under a contract address, you'll be able to see there the names of the methods that were called, as well as in our transactions, you'll be able to see that too. This is something you could use in your DApp to be able to detect certain method calls or to convert a 4-byte signature into the human readable text signature and vice versa. Well, cool. That was the last endpoint. So my hope is by going through each of our endpoints and seeing our Web3 data API and how it works, that your head is full of so many ideas of different ways that you can employ this either as a DApp developer, even as a trader, data scientist. There's so many use cases here and it's so powerful. We're just really excited to see what you guys go out and do with it. Look out for other videos about our platform and please feel free to reach out to us through social media or email. And as always, stay awesome.